Printed part plays role in prototype plane plunge. This is a single incident PrintFix Friday, dealing all about the plane crash with a 3D printed part to blame. So, let's get into it. I bet a lot of you have seen this on your feeds of sorts, whether it's Instagram, Facebook, TikTok, LinkedIn even. And to the almost dozen of you that sent it to us or tagged us in it, you knew this was coming. We have a plane crash after 3D printed part collapsed. Getting a look, one, it doesn't look like it was printed very well, but two, we can see that this is basically an induction elbow for the plane. So as the plane is flying, this is what directs air into the motor to, make everything suck, squeeze, bang, blow the way that it's supposed to. But we can see that this part didn't handle the heat. We can certainly see that there were some issues on the underside of it, and that, well, eventually the glass transition temperature got to it. We can see that the user actually bought the part at an air show in the USA, and they understood it from the vendor that the part was printed in a carbon fiber ABS, material that, in theory, has a glass transition temperature of 105 degrees Celsius, which should work for most engines. It's close, certainly, but when it's an airplane and you have a fair bit of air running through the plane, you don't have these issues. And apparently because the CFABS material had a higher glass transition temperature than the original epoxy resin part that was on the plane itself, they were satisfied with the 3D printed part, and it was fitted for use in the application when it was installed. And we can see that when they actually measured the printed part, the glass transition temperature in two separate spots was 52.8 and 54 degrees Celsius. So it sounds like the person who sold the part lied, or the manufacturer lied to the person who bought the material. This is a huge issue. You guys have heard us talk about some of the work that we do at 3D Musketeers often, and if you want to know more about it, I'm sure we talked about it on our recent podcast episode, and quite frankly, if you want a dedicated episode about how we run our business and what we do, let me know and we can make that kind of thing happen. There is something with airplanes that as a 3D printing service bureau, we will not touch with a 10-foot pole unless we are using FAA certified material. You might say, but Grant, I don't know of any material that's FAA certified. That's to be expected because there's only a couple. One of them being Ultem, aka polyether imide, aka the thing that your flexible build plates are made out of, or at least that top surface, PEI. That material is certified for flight by the FAA as long as it is printed to the proper standards of an Ultem 9085 or Ultem 1010 part. But machines that can print that are few and far between and often cost at a bare minimum $10,000, which reminds me, we just got an HT90. You guys want to see how we would do something like this, but, not printed out of something that's incredibly not made for the use case? Let me know. But I would say that the user of this experimental aircraft was absolutely incredibly lucky. So much of this went wrong in the right ways. Hear me out. We can see the plane here in a couple of photos. And if you notice, the motor, it's in the back. Most planes, the motor's in the front. This is a pusher style aircraft. So if your motor does fail, it's at least behind you, not in front of you. Further, in the actual accident photos, we can see that they got pretty lucky. Just kind of smashed the nose cone of the plane up. And, well, the cockpit is in good shape. Now, planes like these are likely fitted with an experimental license. That's what they would be here in the United States, where you basically don't have to follow FAA protocol. So they are able to 3D print parts on their planes without any issues whatsoever. But we get into a huge liability problem here of who is technically at fault. You could easily say the pilot themselves is at fault because they should have known better. You could easily say that the 3D printer is at fault because they should have known better. But my eyes are square on the manufacturer if they sold the individual who was doing the 3D printing what was listed as carbon fiber ABS and was not actually carbon fiber ABS, because carbon fiber ABS doesn't even get soft at those temperatures, let alone have a glass transition temperature in the 50 degrees Celsius mark. We've talked about this before in that if you're going to do mission critical components, and I think we can all politely agree on this, that an air intake for an engine is what any of us would consider a mission critical item. That you use a certified material from a verifiable source, a source that will give you MSDS, maybe, TDS for sure, and will actually stand by their product. In theory, you'd like it to be someone who's reasonably local to you. Also, make sure that you're testing this out beforehand. Subject the part to heat. It's not difficult. Go get a toaster oven from the local thrift store, throw the part in it with a thermometer, and see when it starts to deform. If it deforms earlier than you think, this isn't going to work. Now, as far as I'm personally concerned, I think that this issue is just a wild case of every single person down the line screwed up. I am all for 3D printing parts for your aircraft. We've made plenty of parts for airplanes, in fact. Some of them non-mission critical components, like sun visor clips and things like that. But any of the mission critical components that we have made, including engine couplers, hydraulic couplers, a couple of other systems that connect things to other things. I just don't want to keep saying couplers. We have always used a certified material, a certified machine, and we have followed the FAA protocol for making sure that Ultem is safe. And yes, we have Ultem capable 3D printers at the shop. But realize parts like that cost hundreds, if not thousands of dollars, even for a little tiny part. An air intake piece like this should cost hundreds of dollars. And quite frankly, this is not the place, in my opinion, for a 3D printed part. We see that one of the traditional ways of doing this is a bidirectional glass fiber cloth with epoxy resin, aka fiberglass and epoxy resin. And, well, the 3D print in theory should have handled more. But we run into a couple of particular issues. One, color. Fiberglass is like this weird kind of off-white yellow color once it's been doped with epoxy and it's hard. Sometimes it gets sanded, painted, whatever, but raw fiberglass and epoxy has like a envelope yellow color. The 3D printed part is black. And when you are dealing with a lot of radiative heat, the color black absorbs a lot more of that energy than something that is eggshell yellow. The thing with airplanes is that if you're playing with experimental aircraft, there is a lot of things that you can control. There's even more things you can't. Wind is one of the things that you generally can't control. Yes, you can use your control surfaces on the aircraft to move air in areas that you want, but if you don't have a dedicated system for cooling a part, chances are it could get nice and toasty. And we can see that the planned safety action here includes a alert regarding 3D printed parts in aircraft, and I fully support this alert. Yes, you are welcome to 3D print effectively whatever you want for whatever reasons that you want, but you must also remember that if you're going to trust a 3D printed part with your actual life, you should be making sure that everything is, well, up to spec. And the trust me bro, it's definitely ABS, it doesn't cut it when you're literally stuck on a low altitude approach and have no other method than to just ditch the aircraft. So where does this leave us? I hate when this kind of stuff happens because you can very safely 3D print parts for planes. And in fact, most commercial aircraft have parts on them. But when they're done by commercial companies, they know what they're doing. Similarly, if you owned an aircraft like this and came to 3D Musketeers and asked us to print this part for you, we would tell you absolutely not, unless you wanted it out of Ultem. And at that point, you might as well just go get it made of aluminum because it will be stronger, it will be more affordable, and unless you are really trying to skimp on weight, there's really not a downside to using thin-walled aluminum here versus a 3D printed part. Is it a cool thing that this worked for a at least small amount of time? Hell yeah, it's cool. It's super cool. Until it collapsed. And then it wasn't cool, because it was warm. Thankfully, the pilot is okay. Nobody was seriously injured as a result of this accident. A little bit of property damage, but hey, it's the UK. It is what it is. I hope that this just goes as a lesson for those of you out there that are looking to start 3D printing businesses to very much make sure that the actual parts that you are making are what they claim to be. And that if you know these are mission critical components, that you are testing them, and especially if you are in the United States, that you are licensed and insured to do those kinds of parts. Because if you're not, and something like this happens, and people die, guess who's gonna get sued? It's you. So I would say at the end of the day, the aircraft is gone, couple of lights are gone, the individual is fine. This is very much a phenomenal learning lesson that doesn't involve a much more detailed report of serious injuries to the individual. But coming from someone who's been in this industry for over 15 years professionally, this was dumb. They shouldn't have done it. They should have known better, and whoever 3D printed the part for them should be worried. This could have been much worse. And now we have an issue. What about all the other parts that were sold by this vendor? What about all the other pieces that are on other aircrafts? If they aren't mission critical, then there's no harm here. But if they sold an intake induction elbow for a plane made in the 90s, chances are they had a lot of other pieces that were mission critical for other airplanes as well. So if you have 3D printed parts on your experimental aircraft, or non-experimental aircraft for that matter, and you can't validate exactly what it is, and you are just applying the trust me bro logic to it, please go to your hangars, garages, don't know, don't care, check your dang planes. I appreciate everyone sending this over to us. I've taken a couple of days to let this kind of sink in, and I wanted to be a lot more critical of this, but I realized that being critical doesn't solve the problem, and instead I'm hoping that we can turn this into a teachable moment. And I'd love to know from you all down in those comments. Have you done a 3D printed part that in theory should have worked perfectly fine, but in practice completely failed? And how did that fail? And what did you learn from it? I want to turn the comment section of this video into a learning opportunity for those out there that are, one, looking to start a business and trying to learn some things, but two, those that have effed around and found out. What did you find out? Share it with the class. And a huge thank you to those that share a little bit from their wallets every single month, whose names are listed right next to me at the $5 tier and higher. Thank you so much for what you all do in making videos like this possible. If you do like this and want to see more, you can always subscribe and leave a like. That is all we have for you all today. Stay safe out there. Don't forget to call your loved ones. And as always, keep making awesome. The cat was here the whole time. Have a good one.